dugsiga boardingka iyo maalinlaha ah ee Amano Boarding and Day School.
Hello Form 1s, good morning everybody, and I welcome you to this tutorial. In our last tutorial, we are looking at acids and bases. We looked at the physical properties of acids, and now in today's tutorial I want us to look at the chemical properties of acids. Chemical properties, we mean reactions of acids. One, we have reaction with metals. Acids react with metals above hydrogen in the reactivity series, and they form a metal salt and hydrogen gas. As you can see here, this is our acid reacting with a metal, giving us a salt and hydrogen gas. An example, we have hydrochloric acid reacting with sodium, giving us sodium chloride and hydrogen gas. Another example, we have sulfuric acid reacting with magnesium. This is our sulfuric acid, if I can write it in a proper way. Reacting with magnesium, giving us magnesium sulfate and hydrogen gas. We come to the second reaction, that is reaction with metal carbonates. Acids react with metal carbonates to form a metal salt, carbon dioxide, and water. Here we have our acid reacting with the metal carbonate, giving us salt, carbon dioxide, and water. Let us take this example. We have nitric acid reacting with sodium carbonate, giving us sodium nitrate, this is our salt, and carbon dioxide plus water. When you look at we come to our reaction 2. That is reaction with the metal oxide. All acids react with metal oxides to form a metal salt and water. For example, we have our acid reacting with a metal oxide, giving us metal salt and water. We have another example, that is nitric acid reacting with magnesium oxide, giving us magnesium nitrate and hydrogen gas. For example, I have my nitric acid here reacting with magnesium oxide, which is my metal oxide, giving me magnesium nitrate and water. We come to reaction 4, that is neutralization reaction. When we talk about neutralization, we mean a reaction between an acid and a base to form a metal salt and water only. The reason why we add this word only is because there are some other reactions between an acid and a base or an alkali and other products. If there is a third product, then that is not neutralization. For neutralization, it's supposed to be only salt and water only. Then when we talk about alkalis, they are metal hydroxides and they are always soluble, but they are also bases. For example, we have our acid reacting with a metal hydroxide, giving us a metal salt and water. Let us take this example where we have nitric acid. I have nitric acid here, HNO3, reacting with the base or sodium hydroxide, giving me sodium nitrate and water. Then we come to bases and alkalis. When we talk about a base, we mean metal oxides and oxides and hydroxides of metals. For example, magnesium oxide, sodium hydroxide, any other metal oxide or metal hydroxide is called a base. Then an alkali is a soluble base. And these are usually metal hydroxide, not metal oxides. Most metal oxides are insoluble. So for example, I have sodium hydroxide, potassium hydroxide, and many other hydroxides. You can also define a base as a proton acceptor. Proton acceptor, we mean a proton refers to a hydrogen ion. And when bases dissolve in water, they ionize. For example, I have this sodium hydroxide is a base. It will ionize and give sodium ions and hydroxide ions. Then these hydroxide ions that are formed, they will accept a proton. This hydrogen ion is what we call a proton. So they will accept it, and then they will form water. So that's why we call bases as proton acceptors. We come to physical properties of bases. One, they are soluble in water. They dissolve in water. They turn red litmus blue. They have a pH above 7. And they have a soapy feel. When you touch a base, it's like you have touched soap. And they are good conductors of electricity. And also, bases conduct electricity when in molten or solution form. But for alkalis, when they are solution, they conduct electricity. We come to reactions of bases or chemical properties of bases. One, we have neutralization, and we have already looked at neutralization, and we said it is a reaction between an acid and a base to form a salt and water. Only two products are formed. For example, here already we use sodium hydroxide and hydrochloric acid, giving us sodium chloride and water. We come to uses of bases. One, we use bases to make soap, and also we use bases as reagents in the school laboratory to test for ions, and you've seen this, we have used it a number of times. Now we have what you call pH. pH means the degree of acidity or alkalinity of a substance. How much acidic or alkaline a substance is. Then we have what you call a pH scale. pH scale is just a numerical scale, a scale of numbers, just as you see a ruler, which is used to show how acidic or alkaline a solution is. And this scale ranges from 1 up to 14. For example, it goes from 1 up to 14, and extremely acidic substances have a pH that is below 1, that is 0 point something. Not negative, we don't have, because our scale runs from 1. Then all acids have a pH value that is below 7, and alkalis have a pH value that is above 7. So the higher the pH value, the more alkaline the solution is. if it is 8, 9, 10, meaning 14 is more alkaline than 8 or 9. Then for acids, the smaller the value, that this is our pH scale. You can see it running from 0 up to 14 or 1 up to 14. And I said 7 is the pH for water, neutral. You can see as the number becomes smaller, the more acidic the substance is. Meaning that a substance with pH 1 is more acidic than a substance with pH 6. And then for alkaline, as the pH value increases, the more alkaline the substance is. Meaning that pH 13 is more alkaline than 9. Then lastly, we have what we call a pH indicator. An indicator is just a substance used to detect whether a substance is acidic or basic or alkaline. And here we have examples of indicators. We have litmus papers. We have a red and a blue one. The red in acidic media, they all appear red, whether blue or red. Then in alkaline media, they will all appear blue, both red and blue. Then in neutral media, the red will be red and the blue will remain blue. All these, it's a paper. Then these are solutions where we have phenolphthalein, which is colorless in acidic media, and pink in alkaline media, and colorless in neutral media. Then the universal indicator, acidic media is red and blue in alkaline media. But this universal indicator has a number of colors depending on the pH. So we come to universal indicator, how to use it. You just get a drop of the universal indicator, you add it to the substance you are testing, you shake, that substance will turn to a given color, then you compare that color with what you call a color chart. Or as the universal indicator has a color chart, then you compare, then you read the pH in that color. For example, when you look here, we have an example of a pH chart. These are the different colors, as you can see, and then these are the pH values. So you compare which color is corresponding to the color of your solution, and then you read the value. Then you know that my solution has this pH. So thank you for watching, and there is this assignment which I would like you to try and then submit in the next 30 minutes. Thank you so much. Have a good day.